In this video, we consider a second method of finding the volume of a solid of revolution. Called the shell method. All right, so let's first consider a cylindrical shell. Right, as such. Right, now it's going to have, let's say it has an inner radius of little r, an outer radius of big R. And it's going to have a height h. Now notice that this shell, right, is obtained by removing a cylinder of radius little r from the larger cylinder of radius big R. Right? So volume would be the volume of the larger cylinder minus the volume of the inner cylinder. Right, now we just algebraically simplify this. We can factor out a pi h. Difference of squares, so we have big R plus little r times big R minus little r. But call the difference in the radii as delta R, which we call the width of the shell. If we suppose that the shell is very thin, then what we find is that big R and little r are about the same, which allows us to say volume is about 2 pi capital R H delta R, which is simply the surface area of the outer shell times its thickness. Now, let's take some curve f of x, right, over a to b. Take its region, take the region under it, unlike with disk, let's now rotate it about the y-axis and consider what happens. Well, let's see if I can do this. I'd probably get something like this, right? Now, what if we take a small region? Let's call it xi minus 1 to xi. Now, what happens if we rotate that region? Well, wouldn't we get something that looks like this? Right, it kind of looks like a cylindrical shell that we get. Right? So we tend to get a cylindrical shell. Now, each subinterval obviously has length delta x. Right, if we divide into n subregions. Right? So notice that the solid can be divided into n thin concentric shells. So V sub I, right, would be approximately 2 pi. Its radius is x sub I, right? Times its height, which is f of x sub I, times its width, which is delta x. This means that the total volume, right, is the sum of all these volumes, which is the sum, I equals 1 to n of 2 pi x sub I, f of x sub I, delta x. Now this is a Riemann sum. So by taking the limit, we will get our method. So the volume is V equals 2 pi times the integral from A to B of x times f of x dx. Right, so this is the shell method. Now again, it's important to note, as it was with disk method, let me actually use a highlighter, that this is for rotating a region under f of x about the y-axis, right? Disk method was for the x-axis. Right, so as an example, let's go ahead, find volume of the solid obtained by rotating the region under the function f of x equals 1 minus 2x plus 3x squared minus 2x cubed over the interval 0 to 1 about the y-axis. As with disk method, let's try and get a picture. And so we want region under y equals 1 minus 2x plus 3x squared minus 2x cubed over 0 to 1. Right, so here's our region, and remember, this is being rotated about the y-axis. So volume, 2 pi, integral from 0 to 1, x times f of x dx. Right, so we get 2 pi times the integral from 0 to 1, x minus 2x squared plus 3x cubed minus 2x to the fourth dx. So 2 pi, right? Antiderivative, we get x squared minus 2 minus 2x cubed over 3 plus 3x to the 4th over 4 minus 2x to the 5th over 5 from x equals 0 to 1. So it's just 2 pi times a half minus 2/3 plus 3/4 minus 2/5. When x is 0, the whole thing goes to 0. We get 2 pi times 11 over 60. And so we get 11 pi over 30 as our volume. All right, now we're going to consider the region that is enclosed by f of x equals x times 5 minus x, and g of x equals 8 minus x times 5 minus x. And again, we're going to rotate this about the y-axis. And so here's our region. And again, being rotated around the y-axis. All right, so first we need to determine our interval, right? So that boils down to we need these points of intersection. Well, if we just look at the graph, it looks to be between 1 and 4, right? However, remember, graphs aren't always to scale. We can easily verify this. Right, by using the solve command. So we're going to set the two curves equal to each other. All right, solve that for x. Let's see what we get. We do indeed get 1 to 4. So the volume, 2 pi times the integral from 1 to 4. And now we can see that the x times 5 minus x is larger, right? The blue curve. Right, so we get x times now their difference. Right? Because remember, we're looking for the radius. I'm sorry, we're looking for the height of the region, right? Well, that is the height of the larger shell, right? This would be the height of the smaller shell. So obviously the height of the shell obtained by rotating the region is the height of the larger minus the height of the smaller, right? So that's why we do this. All right, so now let's just try and simplify this as much as possible. Find the antiderivative. Get negative x to the fourth over 2 plus 10 x cubed over 3 minus 4x squared, and we want to evaluate that. X goes from 1 to 4. So x to the fourth, 4 to the fourth is 128. Divided by 2 is 64. And that should be negative, I'm sorry. Then we get plus 4 cubed is 64. Right. I'm sorry, 4 to the fourth is not 128, it's 256. All right, so that'd be negative 128. Right then, plus 4 cubed, 64 times 10 is 640 over 3. Then we get minus 64, then plus 1/2, minus 10/3, plus 4. And that whole thing evaluates out to 45 times pi. So the volume of this solid is 45 pi. As a final example, we're going to consider the region under f of x equals x to the minus half over 1 to 4, rotated about x equals negative 3. Okay, well, let's try and get a clearer picture. All right, so let's plot x to the minus half. Just don't want plot, I want contour plot. Now let's see what this happens. See, that's what I was afraid of. Let me go ahead and make use of this. So I'm going to go ahead and draw the X and Y axes. Oh, I just noticed, I apologize, that this didn't give me a full picture of what I wanted. So let's fix it so that we're going from -4 to 4. There we go. Now I will draw my X and Y axes. Okay. Let's go ahead and draw our region, right? So our region will be there's 1. There's 4. Right, so there's our region, and it's being rotated about this line now. Well, let's adjust this so that our axis of revolution is the y-axis. Well, to do that, what do we have to do? We have to move everything to the right by 3 units. So the new function we're going to look at, called g of x, is f of x minus 3, right? We're translating 3 units to the right. So it's x minus 3 to the 1/2, and now we're over 1 plus 3 to 4 plus 3, right? Because, again, we're translating everything to the right. Now, let's go ahead and look at that new problem. All right, so doing that, there's our region, and it's being rotated about the y-axis. So our volume would be 2 pi times the integral from 4 to 7 of x times x minus 3 to the minus 1/2 power dx. So 2 pi times let's come up here and calculate this using a CAS. All right, we get 32 over 3. And so we get as our volume 64 pi over 3.